For this video, we're going to go into how to name ionic compounds. First thing to look at is the periodic table of charges. You'll notice there are three different sections on this periodic table of charges. The first section is the section outlined by this border. And these are going to be our nonmetals or metalloids, with the exception of boron, which we're not typically going to be using here for our ionic compounds. All of them have negative charges. You'll also notice that the names have been changed to the fact that they will be dropping their ending. So instead of chlorine, we have chloride. So those already have been edited for you in terms of their names. The next section is the shaded metals. And in these, you see one charge and the name. And this is because these are what are called monovalent, meaning they have one possible charge and that is it. So lithium will only ever be +1, sodium will only ever be +2, etc. Or sorry, +1, etc. The reason for this is because of their valence electrons, especially in the two s block ones. It's going to be easiest for them to lose 1 or 2 electrons respectively to be able to attain that noble gas configuration, which also influences then when we have these multivalent ones. Notice the difference here is that we see Roman numerals and we see multiple charges. Because most of these are located in the D block or lower in the P block, we have D and in some cases F orbitals that make a little more variability in the charges they can attain. It's not as straightforward as the shaded metals in what is ideal for them to get that noble gas configuration. And this will influence our naming of them, as we will need to include Roman numerals to indicate what the charge is of the metal in the formula we're trying to name. So take a moment and on the worksheet, pause to color all the metals seen here that have these multivalent charges red. So anytime you see, let's say, iron, I want you to shade it red. Again, take a moment and pause to do that. Next, this is our polyatomic ion sheet. And as you can see, there is many atoms for most of these. So polyatomic meaning many here. And for all of these, they are usually covalently bonded together, but they attain a charge. And that charge is coming from the transfer of electrons. So you see that they're organized by the charges they attain. This whole long first column is a +1 or -1, middle column -2, and then the last column would be our -3 ions. These are just shaded because of the fact that they're all kind of based on the halogens in making, and they're kind of a repeating pattern. So we have hypochlorite, hypobromite, hypoiodite, which are all just 1 O, and then we go without the hypochlorite, bromite, iodite with 2 O's, and then 8s with 3 O's, and then per 8s with 4 O's. Then we also have our one polyatomic cation. And so this is the only time we're going to see an ionic compound that won't start with a metal if it'll start with NH4, because that will be able to lose an electron, which will be involving in transferring of electrons. So again, pause this video and color any polyatomic ion you see after a metal blue. The easiest way to do that is if you're looking at a polyatomic ion, or if you're looking at a metal and you see that there's more than one atom after that metal, it's going to be polyatomic. Now that you have all of these colored, we're going to sort them out. So these numbers in the left-hand column of your worksheet should not have been colored at all. And so we're going to start with these because they're the easiest. And the reason they're the easiest is they're both going to come from this side of the periodic table. So from the periodic table of charges directly. And we're simply going to name both parts. So we look up what K is, it's potassium. We look up what chlorine is, it's chloride. So the name of this is going to be potassium chloride. And like I said, they're all pretty straightforward like that. You figure out what the name of the metal is. The non-metal is going to be in this region here. And again, I've already changed the endings for you, so they already have the proper IDE ending. So you just have to find both of those. So pause the video, try to fill in the names, and then check your answers. One thing to note here is that there are no prefixes. This is something that's going to be part of the struggle with naming, is that you really have to compartmentalize the two different rules of naming. If something is covalent, that's when we're using prefixes, but we are not going to ever use prefixes for ionic. The only time a prefix might come up is if it's part of the name of a polyatomic ion, but we're never adding prefixes ourselves. And the reason for that is if we know the charges of our ions, there's only one option for potassium and chlorine to form a formula, and that's because they both have a one charge. And so it is much more mathematically based than covalent, because covalent has a little more flexibility with its compound structures. So as you can see, we have simply the name of the metal, the name of the non-metal. These are our most straightforward type of naming. The next type of naming is going to be the ones where we have blue colors. So just blue, not red and blue yet. So the blue ones mean that we have one of these shaded metals. So again, monovalent, only going to have one possible charge. But we also, if we colored it blue, have polyatomic ions. And so we have to look at the back to look up the name. Similar to before, it's honestly pretty straightforward. We just are naming both parts. So if we look at our metal for number 4, we're going to see that that is sodium. So we're just going to write the name of that. And then we see that there's more than one atom after sodium. So that is going to be PO4. And we're going to look and see that PO4 is called phosphate. And that is simply the name of it. Now I'm going to skip to 2 other ones that are a little tricky just to explain. So if we look at number 25, we're going to name our metal, which is zinc. Now this 2 on the outside of phosphate doesn't really matter for the name at all. It's just happening to be the formula that was created with the charges of zinc and phosphate together. So identifying this as PO4 is still going to have us name it phosphate. And then if we look at 26, this is when we have our polyatomic cation. And so we see that I colored both blue here because of the fact that there is no metal in this one, but it is still in fact ionic. We'll go ahead and name both parts here. Just like we would, there's not anything fancy about NH4. We just need to know that it is in fact ionic. So this is going to be ammonium. And then NO2 we'll find is nitrite. So go ahead and try to name the rest of these, pause the video, and then check. Okay, here's all the names of them. I did notice that one of our multivalent metals snuck in there. I didn't color it red, so we'll get to that on the next slide. But iron is not listed here, so I cannot name it yet because we have to go over the rule of how to name iron. Okay, the last slide I'll add the one from here, FeSO3, to explain. Has a mixture of blue and red. Now, notice that some of our second things have blue, some don't. The second thing is always pretty straightforward to name. We're always just going to look up what the name of it is. So if it's polyatomic, we need to look on the polyatomic ion sheet here. If it is not blue, then we're looking for the name of it in our kind of non-metal section over there. Now with the red ones, you'll see that we do have multiple charges. And so I had you color it red because it is going to signify red, meaning Roman numeral. So I need to name the metal like normal, but I also need to figure out what the charge of the metal is. So I'm going to kind of just shell name it first, and then we'll go back and figure out what charges make sense. So we have iron. I need to know the Roman numeral, so I'll just kind of put a placeholder for right now. And then this is polyatomic. If I look up the name, SO3 is going to be named sulfite. Now, in determining the charge of iron, a little detective work needs to go into play here. We see that iron can be either a 2 or a 3 charge. And we need to figure out what it is here. And the thing that'll help us the most in determining that is thinking about what the charge of the anion is, the polyatomic ion. We know that the charge of the polyatomic ion is 2. And we don't see a 2 here. And the only reason we wouldn't have it cross over is if it was able to cancel, which means that they must have the same charge in order for it to reduce to 1. So since we have our two options, iron 2 or iron 3, this is going to end up being iron 2, just because of the formula. And a way you can look at that is in making your formulas using the swap and drop method, which we'll talk more about in class. We would take our 2 charge and our 3 charge. If we had the other type of iron, iron 3. So swapping the charges and dropping them down. So I'll kind of swap them first. We only want to bring the numbers over when we're swapping. Definitely put the wrong charge there. So that would give us the formula we have, FeSO4, so 3. And then here, I'd go up into this space, we would swap the charges first. So Fe, we have the 2, SO3, have the 3, and then we would drop them down as subscripts. We had Fe2 here. We would need parentheses for our polyatomic ion if we're going to put a subscript on it. And so that would end up being 3. And so because this is the formula we have, and this is not the formula we have, we must know that it is a +2 charge. And it becomes a little more obvious once you get familiar with making the formulas. But if we look, we'll go kind of 16 through 24 since those are all iron. Iron only has 2 options. So we'll name the parts first. And then kind of go through the logic steps of how we would figure out what the charges of each iron was in each case. So here, SO4 is sulfate. Cl would be chloride from this area here. Br, bromide from this area here. And then O would be oxide from this area here. We know that iron should either be 2 or 3. So looking at, again, kind of the charge of our ions, this is a -2, -1, -1, -2. If we are not seeing for 16 and 24 a 2 crossover from the negative charged ion, that must mean it canceled with iron's charge, which means iron would have to be the same as that ion. So here we're going to get iron is 2 and iron is 2. Now looking here, this subscript would have come from iron, so that's going to be iron 3. This subscript also would have come from iron, so that one's going to be iron 2. And again, this is the most challenging part, but a lot of it will become easier the more familiar you get with what the kind of process of actually making the compounds is. So we'll go ahead and try with our copper here. So we have copper sulfate and copper acetate. Sulfate has a -2 charge. Acetate has a -1 charge. We don't see anything crossing over from the copper, so that must be copper 1. Again, copper only has 2 options here. And here we don't see anything crossing over from the copper or the sulfate, so they must have canceled. So that's copper 2. And then the last one is chromium. We see a 3 here. So that 3 must have come from chromium, and as we look, chromium does have the option to have a 3. So that'll be chromium 3. It's a little easier when we see a subscript crossing over, but it gets a little tricky because we have to make sure that those are actually new subscripts like they are in this bromine and not subscripts that are part of the polyatomic ion. Okay, I would like you to try the other column on this worksheet, and then we will go over it during class.